Now let's go over odd and even sort. Now odd and even sort is also known as brick sort, and this is another variation of bubble sort, just like cocktail sort. But compared to cocktail sort, there is one major problem that odd and even sort doesn't handle, and that's the turtles problem. But again, this odd and even sort is just another variation. It just works differently. But just know that it's not as optimal as cocktail sort. Now, how odd and even sort work is it's going to compare and sort adjacent elements, but it's going to do it a little differently. And as you probably guessed from the name, it's going to alternate between sorting odd and even odd pairs. So let's say that we have an array. So here we handle positives, negatives, and duplicates. In the first iteration, it's going to look at the odd and even pairs. It's these two. So this is index 1, index 2. And then it's going to look at these two pairs. Next, these two pairs. And it's going to swap if necessary. So after first iteration, we're going to have this as our result. Here we did odd and even pairs, right? And now it's time for us to do even and odd pairs. So that's 0 and 1, these two numbers, and these two numbers. And it's going to check, well, do we need to make any swaps? If we do, we're gonna make the necessary swaps, and this is what we get. And then again, we do our odd and even sort. So that's these two numbers, these two, and these two. Now that was odd and we do even and odd. And we check again, do we need to make any swaps? Now we get our sorted array, and we do odd and even again, just alternate between odd and even and odd. And last operation, and finally we get our sorted array. As you can see, again, we do odd and even first, even and odd even odd, even odd. So that's a pattern, hence the name odd and even sort. Now, another key thing is, we briefly talked about this. Unlike cocktail sort and comp sort, which we didn't go over yet, but it doesn't solve the turtles problem. And if you remember what turtles problem is, it was something like this. So if we had an array of 2, 3, 4, 5, and 1 happened to be the smallest number, right? And if you were to use bubble sort to sort this whole array, it would take total of 4 passes. So at first, we're going to have 5 at the end, and 1 is going to move 1 to the left. Next, 4 is going to be in the correct spot, and 1 is going to move 1 to the left, 3 in the correct spot, 2 in the correct spot, and finally, later, 1 is going to be in the correct spot where it's index 0. So bubble sort is good at handling moving large elements that is in the beginning of the array to all the way at the back, but it's bad at handling the turtles, which is this number 1. It's going to move this number 1 once to the left per iteration. So that's going to take a lot of time, and that's all of n squared job. So is there a way that we can quickly do this? And for cocktail sort, we were able to solve this problem by alternating our directions. So for the first iteration, we are going to the right and then coming back left. So that was one iteration or one pass, right? But unlike cocktail sort, odd and even sort actually doesn't solve that problem. So this is actually kind of not as optimized as cocktail sort, but I think it is good to go over. And of course, we will go over comp sort later. Now let's just go over our time complexity. And if you noticed, again, it's similar to our bubble sort, and it's O of n when it's already sorted. So this is our average case, and worst is exactly the same, and when the array is in reverse order. And space is going to be O of 1 because we are using in place method, so we are overriding our result to the original input array, so we don't need any more extra space. Extra space that is going to take is for auxiliary variables. Other than that, there is no space needed for even and odd sort. Now that's it, and let's get to our solution. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's go over our solution, which is going to be the optimized in place method. And if you are not too familiar with how bubble sort work, definitely go back and check the previous video because you will have such a better understanding of how odd and even sort work after you learn how bubble sort work. Now I do have my pseudocode, and if you read along the pseudocode, you will notice that it's really similar to bubble sort. And the reason is because this is just another variation of bubble sort. Makes sense, right? So let's just go over our pseudocode. So for step 1, we're going to obviously create our function that takes in a parameter of our input array, and we are going to create our swap function, and I have that over here. Next, we want to create a variable to check we swapped or not. Next, we are going to create a do while loop, and we are going to run as long as swapped is equal to true, and we're going to set swap to false and handle odd and even pairs first. So we're going to iterate through the array starting at the odd index. That makes sense, right? Because this is odd and even pairs. So we're going to check if the adjacent element is smaller than the current one, we're going to swap, and we're going to set swap to true. So we're going to do that for all the odd and even pairs. And after we're done with that, we're going to handle even and odd pairs. So we're going to iterate starting at even index. So that, again, that makes sense because we're done with odd and even here, and we want to do even and odd pairs now. And same as before, we want to check if the adjacent element is smaller than the current one. If it is, we're going to swap and set swap to true. And we're going to do that for all the elements in our array. And finally, return the sorted array. So we should have a less than sign here. Now that's it for our pseudocode. Give it a go, try your best, and if you got bubble sort, I don't think you should have too much trouble implementing this one too. Okay, now let's start coding our solution. So first thing I'm going to do is I'm going to make a variable named swapped, and this is going to obviously check if we swapped or not. And I'm just going to declare it here. And next, I want to make a do while loop. This is going to run as long as swapped is equal to true. And finally, we are going to return our array. Okay, that looks good. Now, what I'm going to do is I'm going to set swapped to false. Now, I need to handle my odd and even pairs first. So I'm going to make a for loop, and this one is going to start at I is equal to 1 because we want to do odd and even pairs. And this is going to run as long as index is less than array.length. And we're going to increment the length by 2 each time. Because if you were to increment it by 1 each time, that wouldn't really compare sorting on the odd and even pairs. So if you were to start in the first loop, it's going to start at 1, and adjacent element would be -2. But if you were to increase this by 1, it would start at -2 and check 2 as the adjacent element. And that's not what we want. We want 3 and -2, 2 and -1, 1 and 0. So that's why we're incrementing by 2. So now we need to check if our adjacent element, which is represented by I plus 1, if this is less than our current element, what do you want to do? We want to swap. So let's call our swap function, pass in the indexes, and then swap. And finally, we want to set swapped to true. Okay, that looks good. And now we need to handle our even and odd case. So this is going to start at index I is equal to 0 because 0 is an even number. And we're going to do that as long as length is less than I, or I is less than length. And same as before, we are going to increment by 2. And we need our same if case. If the adjacent element is smaller than our current one, we want to swap, pass in our array, index, and the other index. And finally, we want to set swapped equal to true. And as you can see that we have our sorted array. And let's just uncomment this one. So array with 100 random elements and check if it's swapped. So starting at -99, everything seems good all the way to 100. Yeah, everything's sorted, no problems. Now that we know this works, let's just uncomment this and try to go over the code itself. So for this one is handling what pairs? Odd and even pairs. And other than the fact that our index starts at 1, there is really no difference between bubble sort and this. Well, again, we are incrementing by 2, but disregarding that, it's exactly the same thing. Whatever we have inside here is the same thing. It's just this part that's different. And our second loop here, this is handling even and odd pairs. And this one starts at index of 0 because again 0 is an even number. We do that for all the elements, or we do that until I is less than the length of the array, and we increment by 2 again. Same as before, All this is same as bubble sort. And when we're done with all this operation, we return our array. So do while loop again ensures that this whole thing runs at least once and then checks if swapped is true or false. If it's false, obviously this is going to not run one more time and is going to return our array. And when this do while loop runs, just to go over, just to make sure, it sets swap to false, right? So it's going to run this for loop, and if we don't make any swaps, our swapped variable is going to be false, right? It's not going to change to true. So what it's going to do is it's just going to turn this into false, and then it's not going to run anymore. And if it's false, that means that all the elements are already sorted, right? So we don't need to do any more checks, comparing, and sorting. So finally, we return our array and get our result. If you guys find this helpful, make sure you guys like and subscribe. Thanks.